Oh, hello, I didn't see you there. Welcome back to Calculations with Christel. Today we are going to be learning something new from the geometry textbook. Please open your geometry textbook to page number 137, which is chapter 3, entitled Parallel and Perpendicular Lines. Please come with me to the whiteboard. In the first section, section 3.1, we're going to be learning about parallel lines. Here is how the parallel lines examples usually look like. And so there are 3 different ways we can find parallel lines in this section. So the first way is the alternate interior angles. These are non-adjacent interior angles that lie on opposite sides of the transversal. So in this example, the alternate interior angles would be 4 and 6 and 3 and 5 because they are on the inside of the section and they are parallel to each other. The next one is called same side interior angles, and these are interior angles that lie on the same side of the transversal, which means in this transversal it will be either on the left side or on the right side. So the example in this transversal for same side interior angles are 4 and 5 and 3 and 6. Because you have to make sure that it's on the interior angles, which means it's on the inside. And finally, we have corresponding angles, and these lie on the same side of the transversal and in corresponding positions. So there are quite a few in here, so we'll name a few. So one example would be 1 and 5 and 4 and 8 because they're on the same side and they are corresponding to each other. So that is what section 3-1 covers. The next section, section 3-2, we're going to learn about properties of parallel lines. And one example of this is the same side interior angles postulate. And this is if a transversal intersects 2 parallel lines, then same side interior angles are supplementary. If line L is parallel to line M, then M angle 4 plus M angle 5 equals 180. And if that is true, then M angle 3 plus M angle 6 also equals 180. So that is the same side interior postulate. In the next section, section 3-3, we're going to learn how to prove lines parallel. And one way to do this is through the converse of the alternate interior angles theorem. So this theorem is that if 2 lines and a transversal form alternate interior angles that are congruent, then the 2 lines are parallel. So here you can see that angles 4 and angle 6 are congruent. So if those angles are congruent, then that means that line L is parallel to line M. And that is one way to prove lines parallel. The next section is section 3-4, and we are going to learn about parallel and perpendicular lines. And one theorem is the perpendicular transversal theorem. And this theorem means that in a plane, if a line is perpendicular to one of 2 parallel lines, then it is also perpendicular to the other. So here, if N is perpendicular to L and L is parallel to M, that means that N is perpendicular to M, and N is right here. So it's perpendicular to M. The next section, section 3-5, is called parallel lines and triangles. So one of the theorems is called the triangle angle sum theorem. Here you have a triangle with angles A, angle B, and angle C. So the sum of the measures of the angles of the triangle is 180, which means that this triangle as a whole equals 180. Measure of angle A plus measure of angle B plus measure of angle C all totals up to 180. In section 3-6, we're going to learn how to construct parallel and perpendicular lines. So in this particular example, we are going to have a perpendicular line from a point to a line. So it's point R to line L. And in order to complete this task, you are going to need a compass, but I'm going to show you how to do it with the whiteboard marker. So we are given line L and point R, and we are trying to construct line RG, so R to another point that will be there, point G, which is going to be perpendicular to the line L. So you're with your compass, you are going to take your compass and you want to put the pointy part on line R, and you want to take it and swing to make this shape. And then you are going to take the compass again, and so there are going to be formed points right here. So that's going to be point E, and this is going to be point F. And from one of those points, you are going to put the pointy side on it and then create a slash right in the middle. And then you're going to do the same thing with point F to make another slash down the middle. And then you're going to construct that to point R. And that is how you find a perpendicular line from a point to a line. In section 3-7, we are going to be learning about equations of lines in the coordinate plane. And we are going to talk about forms of linear equations. So this first form is called the slope-intercept form. And the slope-intercept form of an equation of a non-vertical line is y equals mx plus b. Here we can see that m is the slope and b is the y-intercept. The next one is called point-slope form. And the point-slope form of an equation of a non-vertical line is y minus y1 equals mx minus x1. So the y here is the y coordinate, the m is the slope, x1 is the x coordinate. So those are two types of forms of linear equations. The final section, section 3-8, talks about the slopes of parallel and perpendicular lines. So here we are going to learn how to write equations of parallel lines. So what we're trying to do is, what is an equation of the line parallel to y equals negative x minus 5 that contains negative 1/8. So what we need to do is identify the slope of the given line. And so we know that the slope of the new line, and that it passes through negative 1/8. So we need to use the point slope form to write this equation. So we want to substitute negative 3 for m and negative 1/8 for x1 and y1 and simplify. So that is how you write the equations of parallel lines, and you just simplify from there. Thank you for tuning in for this week's episode of Calculations with Christel. Make sure to tune in next week for Chapter 4, Congruent Triangles. Thank you for watching. Have a great day.